A dreidel. This is part of a long heritage of spinning tops. The interesting thing about their operation is that if you were to just put them down on the table and let go, they fall over instantly. But if I spin them, it stays upright for a reasonable amount of time. If I were to throw this dreidel up in the air, you'll see it comes back down reasonably quickly. The reason this happens is because of the force of gravity, which is constantly pulling things down to the center of the Earth at a consistent rate. Angular momentum is, just like normal linear momentum, a quality of an object and its velocity. In this case, it is the velocity of the rotation of an object around its axis. The axis, in this case, being the fun little stick that I can hold this dreidel by. Angular momentum is also conserved, which means that if I start to spin this dreidel on its axis, it will continue to spin on the same axis without moving until other forces take over and it topples over. Another interesting quality of the dreidel, however, is that if I spin it, you will notice that it is not just spinning around its axis. It is also spinning around its point. So the dreidel, while it spins, has a slight slant to it, which means under normal circumstances, if I were to put it down on its edge, the slant would cause the force of gravity to tilt it over, and it would just fall on the floor unceremoniously. However, spinning it causes what's called precession. This is a quality of a spinning object called, it's part of the gyroscopic effect, which causes the force of gravity not to act downward and cause the dreidel to fall over like we would expect, but instead for it to act sideways and cause it to spin. This is why, as the force of friction on the dreidel causes it to slow down and fall over, we'll see that it starts to spin faster and faster as the force of gravity increasingly has a greater effect, and the precession eventually cannot keep up and the dreidel falls to the floor.